In problem number 3, we've got tomatoes, and we've got small ones and medium ones and large ones. And the mean is 90, and the standard deviation is 17.7 grams. It's normally distributed, so we can write it in this form with the parameters of 90 being the mean and the variance being 17.7 squared. Now, the small tomatoes are less than 80 grams, so the probability that the mass is less than 80 is going to be, we're going to change this to a z-score. That's going to be 80 minus 90 over the square root, I'm sorry, not the square root, 17.7, and we're going to get negative 0.565. So now we'll rewrite this as a z-score. Z is less than negative 0.565. Now the problem is we've got this negative z-score. We want to be less than, but we also want it to be a positive z-score. So what we're going to do is rewrite this in a way that it does the same shape, but it has a positive one. And if I rewrite this with its symmetrical brother of 0.65, I can do 1 minus the probability that Z is less than 0.565 and get the same shape. So what I'm going to find then is the probability is 0.2860 or 28.6%. Now, if you take a look at the median ones, then we've got from 80 to 104. If I rewrite this as a probability, it's going to look like this: the probability that m is less than or equal to 104 or greater than or equal to 80. Now, we already know the z-score that goes with 80. We just figured that out. That's negative 0.565. All we got to do is figure out the z-score for 104. 104 minus 90 divided by 17.7. That's going to give us a z-score of 0.791. And so now all we've got to do is do a quick sketch. We find out that the 1 is negative. We knew that all along. It's over here. Then there's a 0.791. It's going to be over here. The area is going to be between them. So if I find the area below 0.791 and then subtract the area that's below negative 0.565, I'm going to have this area, this column in the middle. When I use my calculator, I'm going to find out that the probability of it being less than 0.791 is a z-score. I'm going to find out that's going to be 0.785528. And I already know what it's going to be when the probability of the z being less than negative 0.565. We figured that out with the small. So all I got to do is subtract them, and I find out that the probability is 49.9%. Now the large tomatoes, now they're going to be bigger than 104. Now we already know the z-score. The z-score for 104 is going to be 0.791. So the probability that z is greater than 0.791, well, again, we can do this sketch here. It's above this area. So all I've got to do is find 1 minus the probability that z is less than 0.91. Well, I've already figured out what less than 0.791 is. That's this 78.528 thing. So if I subtract 1 from that, or it from 1, I find out that I get 21.45%. Now in part B, they're giving us this probability, and we've got to figure out what K is. Now keep in mind, if I know an area for something below a value, I can find out what that value is using the calculator and the inverse normal. So let's go ahead and do a sketch here. We already know that we've got 104. That's going to be over here. And we even know what its z-score is already. We know its z-score is 0.791. And we know that K is down below here somewhere. And we know that between these is 0.75. Now, we've already figured out what's below 0.791 or 104. That it's 78.5528. That's going to be below it. So what I need is this area below K. So if I take the 78.5528 and then subtract the 0.75, well, then that's going to give me this area on the end, which is going to end up to be 0.035528. And what that basically is going to look like is this little area down here is going to be 0.0355 blah blah. So now let's write our probability statement. We want to find the probability that x is less than k, and we know that that area is going to be 0.035528. Now I set it up as a z-score equal a z-score. The first part I use the z4 formula. The next part I'm going to use my calculator, inverse normal, 7, inverse normal. I'm going to plug in the area, 0.035228, and I find out that that z-score that matches up with that area is negative 1.805. And see, now all I got to do is solve for k, and I find out that it's going to be 58.05 or 58.1. All right, that's all for that one. In number 4, we've got these trees, and their heights are normally distributed. We don't know the mean, but we do know the standard deviation is 3.6. They tell us that 75% of the trees are less than 10 meters high, so the probability the height is less than 10 is equal to 0.75. We can take each one of these and turn them into a z-score, 10 minus mu over 3.6, and then the z-score for the 0.75. Well, all we've got to do is use the inverse normal of our calculator, plug in this area of 0.75. It's below it, so it's going to give us the number we need. It's going to be 0.6744. And now all I've got to do is fill that into our equation and then solve for the mean. Keep in mind, we know that if you draw a sketch, it's kind of helpful. We know that we've got this 10 here and everything below it is 0.75. So all I've got to do now is get mean by itself, and that's going to be 7.57 meters. That's all there is for that one. In 6A, they tell us that children can hop 15 minutes. It's normal distribution with the mean of 199 and a variance of 3,700. So I'm going to write that out here, and they want us to calculate the estimate of B given that 25% of the children hopped further. So all we've got to do now is we know that this is 25%. We do a quick sketch. We see our 25% is over here, and it's got to be above whatever this value is. That means 75% has got to be below whatever our value is. If we use the inverse normal to find below, then it's going to give us what that value B is, or at least we can change these to z-scores. So this is going to be B minus 199 over the square root of 3,700. And then I go to this 0.75 and inverse normal, put in 0.75, which we already had. It's going to be 0.674. And now all I got to do is get the B by itself, and that'll tell us what it was before we made it into a z-score. And we're going to find out that it's going to be about 240. All right, that's all there is for this one. Okay, so we've got the ages in the Gymnastics Club. They're normal distribution. The mean is 15.2, but we don't know the standard deviation or the variance. We do know that the age, the probability of the age being less than 13.5, we do know that that's going to be 30.5% or 0.305. Now, in a situation like this where they give us a probability, we're going to change each one of them to a z-score. So 13.5 minus 15.2 all over the standard deviation. Z-score here, I've got this 0.305. Now keep in mind, that's over here on the left side. It's going to be a negative z-score for sure. It'd be a good idea to go over here and figure out this is 0.305. And then everything to the left of it, well, that's going to be 1 minus 0.305 or 0.695. So all this area over here is 0.695. If we use the inverse normal, it'll give us the value that has everything to the left of that. In this case, any value that has 0.695 to the left of it. Well, in this case, it's going to be 0.51, but remember, we want ours to be the negative one because it's on the other side. Anyway, all I got to do now is get the standard deviation by itself, and I'm going to find out that the standard deviation is going to be 3.33. And that's all there is for that one.